One of the most common questions that people ask me is, how do you know that you're not blowing up your gold when you blast? And I think this sketch will show you how we accomplish that and make a little bit more sense to you. We work 140 feet underground, and what I'm drawing here is a north to south cross section, and these vertical lines that I'm drawing, they represent what is known as the dike. And what a geological dike is it is a formation of rock that came up and filled in a huge crack. In our case, it's an 18-mile long crack that got filled in with this metamorphic material, this hydrothermal material. The circle that I'm drawing now is the tunnel that we work in, and it has been driven or drilled and blasted in the slate. You'll see that I'm drawing kind of parallel lines that are close together, and that's to represent the slate. And what happened is, during the formation of the Sierra Nevada mountains and the North American and Pacific plates collided with each other, they tilted the seafloor up and created these vertical fissures that then got filled in by the dike material. So what we're doing is we actually don't drill and blast in the dike where the gold actually is residing in the quartz veins. We're working in the east side of the dike, and you'll see that I just drew a ladder in, and that ladder represents how we get up into what we call the stope. So now I'm going to show you from a different angle. This is looking to the east, and we're looking at a cross section of the raise up from the second level. We go up a ladder that's approximately 10 feet tall, and then we go about 200 feet to the south into an area that has been shrink stoped, or another way to explain that is this whole area started out at track level at 140 feet, and then as we work our way upward, we are shrinking the level. What I'm drawing in here is all of the blast rubble from previous blasts. So the way we actually avoid blowing up the gold is I'm now drawing in what would be the drill holes. So we drill holes that are approximately 4 feet long into the roof of our working area. And now this is looking at it from the other direction. Again, we drill holes that are about 4 feet long, and you can see that we stay away from the dike. That's where the gold is. When we drill and blast, then what happens is that material comes shooting straight down, and it creates a new floor that we work on. So we avoid drilling and blasting into where the gold is, and instead what we're doing is we're removing the slate out of the way so that it exposes the quartz veins so that we can metal detect them and then find the gold. And you'll see that as we blast, all that material comes down and creates a new floor, and then we just go a little bit higher into the roof area of the slate. So that gives you a little bit of an idea of how we're actually working. And now let's get ready for a blast. And I'm telling you right now, there's just a little bit of swearing in the video, so if you're offended, maybe plug your ears. Haha. Yeah, tinnitus, yeah. So how many millisecond delay do we have?
0.
0. That means when you fucking push that button. Ready?
All right.
Yeah, that was fucking pretty instant.
Did you fucking feel that?
I fucking felt it.
I'm right under the damn thing in it.
Yeah, I felt it.
Did you count them?
There were 6. Something I want to point out here is that Tim asks, did you count them? And then I replied, yeah, there were 6. What we're talking about here are the delays that we use. We don't want everything to go off at once, and so we use delays to direct the material to where we want it to go. I'll talk more about that in the next video, and I'll show you the pile of rock and how we get it to go in a place that we want it to go. So if you go back and listen, did you hear the 6 distinct explosions?